After a short delay with fun setup of video display software, it is my pleasure to introduce Lotfi Ben Otmane. I hope I didn't butcher your name. He's a lecturer at Iowa State, working in different areas of secure software development. And he has traveled quite a bit and come through a whole bunch of different countries, which was interesting to read, including the Fraunhofer Institute for Secure Information Technology in Germany, which was very nice to read. His research focuses on empirical research in secure software development of secure systems using an agile approach, and cyber resilience in connected vehicles. And I'm very interested to hear what he has to say about these things. So please take it away.
Thank you, Matthias. So, as Matthias said, my name is Lotfi Ben Othman. I am with Iowa State University. I traveled quite the world. I think I went through 3 continents so far, and I am here. I came here to share with you my passion for empirical research, and hopefully some probably of you will appreciate that. In this talk, I am going to give examples from my research on 4 roles that empirical research can play in software security. So the first thing probably, who actually did not take course on security so far? So all of you took course on software security. And one question that you had it probably when it comes to threat modeling is that we have, I think probably so far, 60 methods for threat modeling. You could see by this kind of study by colleagues, they did it at the time, and we got it from their slide when it was at Fraunhofer State. So the number of citation or uses of this threat modeling approach. You have fault tree analysis, you have attack tree, you have the MSSDL Microsoft Stride, misuse cases. And for the fault tree analysis, you see for the citation, this is 2014, more than 1,000 paper actually either they worked with the approach, extended, and so on, or actually they apply it, or probably they cite it somehow. So we have a big number, and the question when you go to work with this in real context with this method, your first question, which one I am going to use? Obviously, the simple answer is it depends. But that's good that we have many methods that probably also would help us to identify all the potential threats. Might be. However, we hear all the time about new threats that comes to the wild. I'll give him an example. This is one attack that we got it about 2 years ago. And this is what we name it, use of malicious dependency. In this kind of attack that we identified, you deploy your application, let's say, to the cloud, especially to Node.js. You use specific dependency, but it's possible that in one of the dependency that you used, it changes the behavior of another dependency that you are using. And that's potentially you do not realize that. So that's new, at least we were not aware about it. So simply how this works. So you call, for example, for Node.js, you have the async library in your code, and the code, the dependency that you are using, it's probably going only to give you to change the colors for your formatting, for your HTML. But in this code, there is few lines extra, requires async. It saves the method map in a variable. This is JavaScript, so you could do it. Then there is a redefinition of the map function. And in this redefinition, there is a leak of the events. So you have the events that sync get, which you are using. They will be leaked because you have this leak method. And then the behavior continue because you call again to apply the previous method. So with this redefinition of function, now the map that you are using is not the map of the sync, but actually the new map from the other dependency that you are using. If you did a review of the code, your sync is great. It's not changed. You are fine. But because the other dependency changed the behavior, so you have this attack. So the bottom line here is we have different method. Let's say one of the cases for software security, we have different method for threat modeling, but we are still discovering attacks. More and more we discover attacks. The classic way for cybersecurity, you have problems. We come with a set of solutions. We prove that these solutions are great, and probably we develop a software and so on. This is method one. There is another method. So we've done it for threat modeling. We've done it 60 times, and we are still did not reach probably satisfactory situation. A second approach, that would be collect practical wisdom from expert. You will be graduating like the previous one, like myself, and you go to the industry and you have real problems there. You gain experience. What if we go for all these kind of things that we have? We go to one of the things, we go to these experts. We go to the facts, experts, data, and try to learn from there, from this wisdom. So empirical research method, they are not new. They have been there for social science. They have been there for education, for medicine. So we have the qualitative study. Probably you are aware about this. So for example, the interviews, the case study. This is for medical, for example. Observation. So people, they work, you observe how they do, and you try to derive rules there or common patterns. You have the mapping study. Mapping study implies that there are studies that talk about topic, like now, for example, let's say blockchain, and you want to check what is the stage, what are the aspects that are studied in blockchain. The other category for empirical research is the quantitative study, where you have a quantification here. Like data analytics, you have probably questionnaires and surveys. You might have experiments, so you run things on code and you bring data, common pattern there. Or also for papers, you do systematic literature review. You have a criteria and you want to see how, for example, mature specific field based on specific criteria that you come up with. So we have a set of empirical research methods. Those here, a set of these common ones that we use in software security. And they have been used for other sciences. We could use them also for software security. So I said I'm going to share with you 4 roles. And the first role that empirical research could play with software security, it could help us with improve the maturity of the models, the techniques, and processes that we use to engineer secure software. Let's take the case of risk estimation. So for risk estimation, the common formula that we use is risk exposure equal to impacts multiplied by likelihood. So you get the impact and you get the likelihood. That will define your risk exposure. So the likelihood, it's kind of the attack potential, how likely the attack could happen, multiplied by the frequency, how often is going to happen. Let's say you could use this formula. You might come with different way, but this is kind of common. So I would take here for the connected car. We have now most of the cars, they are connected somehow. You have Bluetooth, you have different devices. And I'm going to say what are the different threats that I have and how likely the threats can happen and what is the impact. So you come and the attack is going to flash the firmware. Or here I would say this is the likelihood, the impact is low. Probably not. You might not agree with me. And the likelihood is low. I would say inject break message. The likelihood this is probably going to be possible. The impact is still probably, I would say probably low. But there is another one, take control. The likelihood is going to be likely low and the impact is high. This is my perception. You might agree with it, you might not. I could give you an argumentation That's my argumentation for why I would say this is low or high. Or I would show you why I came to this conclusion. So we bring this is Rohit. So he was here years ago. He's graduated from here and we worked on this paper together. And we ask, what is the risk exposure of a threat take control of a car? So let's assume that Rohit says this is high risk. I can't say, no, this is low risk. How did we come up to this conclusion, low or high? And the first question, if two people, they come, especially two experts, they come to you, and you are working on, let's say, to develop something, and one says this is high, one says this is low. Who should you believe? So, question, who should you believe? This is actually the one who is going to make the decision. That's what comes to him. So, and I would say, if one says high and one says low, go talk to each other and come with me with a response, something that makes sense. So far, it doesn't make sense. So we have, as I talked before, for threat modeling, we have many methods, and that's great because we have different perspective on things. We have also for risk estimation different methods. So the OWASP, they came with their own factors for estimation, risk estimation. ISO 1845, they have also their own factors there, among other things in that standard. The NIST 830, they have also their own estimation risk. And the OCTAV 2, they have their own estimation method. Let's assume I used, for example, the OCTAV, and Rohit used the NIST SP 830. Everyone used his own factors, the factors that are defined in this document for the estimation of risk. So now we know that we have already two different ways to do the estimation. So we have them here. So I used the motives, the means, the opportunity. What is the motivation? What are the means? And what is the opportunity to do the attack? From the other side, we've seen the capability. What are the resources available from hardware, from the scripts, and so on that you could use to perform specific attacks, and also the intents for doing that or not. And the question comes now, whether you believe Rohit or you believe Lotfi. Now here you are going to come to the point, which factor should I use? We know that we are using different methods, and the question, which factor should I use? We need to use the same factor probably, so we can get to an agreement, right? So whom should you believe comes to which estimate should you use, right? So let's have now two estimation, two threats. We're not going to use only one. The first one is remote update of ECU firmware. And here we have the likelihood, we have the impact. The likelihood, Rohit says 13, I would say 30. How did we come up with these numbers? So we said low, high, and very high. Then we make a scale. If it's low, then 0. If it's high, then 4. Then because you have a set of factors, you compute these numbers, so you do summation. We're going to see that. So we come with different numbers. We come with different estimation, low and high likelihood. For the falsification of speedometer reading, we come also for two different numbers, 50 and 23. 50 and 23, Rohit says this is really very high, and I will say this is medium. Now the question is who to believe, right? So we have an error in this estimation. And the common thing here, I brought this kind of from physics, the document, old document. You have two ways to analyze your error. You have one is you use historical data. You have historical data, and you're going to use that to analyze what is your error. And you have the uncertainty approach, where you're going to measure the bound where the true value lay. And it implies that if you have an agreement, then this is most likely the true value. If the experts, they agree for this case on something, on specific value for the risk, I would say that this is actually the risk. If they disagree, then there is something that is wrong. The first approach, actually, we cannot apply it because we do not have historical data. The day that we have historical data, that's probably the best way to go because you have probably better foundation. So we come to the estimation, and the uncertainty in general, it's measured using the standard deviation, the regular mathematical standard deviation thing. We have here for the simple case, this is the simple one, where you have z, this is the summation for factor xi, then the standard deviation for z, so you have the square root of the summation for the delta xi square. So if we get to delta z that is small uncertainty, then there is an agreement, right? Since we said if this variation is small, then people, they agree. If there is a big variation, then people, they disagree. So a big uncertainty implies disagreement. It's a common thing that we use it for other aspects for the estimation of uncertainty. So we got that. That's the approach. Now we jump which factor we are going to use. And let's say here we had at some point a debate, and we said attacker capability is the ability to access system resources to exercise threats. This is actually, it's a good factor that has really, it impacts the risk estimation, and we should use it. So we say, you cannot use the scripts, you cannot use specific hardwares, you cannot use the opportunity that you have unless you have a specific capability. So, and you have a specific capability, now we have to come up with the likelihood for this capability. So you have now the likelihood of the capability is how likely potential attacker can have this capability. And you could have specific factors for the estimation of likelihood for capabilities, such as how many persons they have, they are around to estimate in that moment, for example, to check the opportunity. So we identify for these attacks two simple attacker capability. One is local access and one is remote access. You might say, when remote access, he can access my Bluetooth, or he can access it remotely using V2V or whatever. So you can go in details. So we specify two access capability, one local access, one remote access, and we give again the same threats. So this is Lotfi, this is Rohit. So how likely is it to have remote update of ECU firmware? So we say for the local access, if I have local access to the car, and I can plug my code in the OBD2 probably, I have Waze scripts, and this is 27% is likely. And I would say 30% is likely. We come to the second thing, and we say falsification of speedometer reading. I would say if I have local access, it's very high, I could do it. So, and I would say, yeah, it's high, but still it's 30. But for remote access, if I have remote access, it's going to be more difficult. So it's 10. And they would say, yes, it's going to be more difficult and the risk is low. It's 15. So you have much work to do and probably more hurdles to do the attack. We see here that 27 and 30, they are not far. 50 and 30, they are not far if we compare them to the previous value where we have, let's say, 50 and we have 10. So for the previous one, we have different exposure, risk estimation exposure, estimation of the risk exposure, and here we have a close one. So we came and we formulated this. So since attacker capability, this is a condition to use specific means and opportunity, then you have the set of factors that you have for each threat. You identify the capability that you have, capability K here, and you want to identify the P. So this is the potential of attack. So you have the factors, but multiply by your likelihood for having that capability. Then you come for your potential attack. It's going to be the maximum of the potential of attacks given the different capability. So you're going to get the maximum for all of them, for all the potential capability that you have. And the risk is going to be the impact for that threat multiplied by the attack potential multiplied by the occurrence. So this is kind of how we compute the attack. So we had the idea on how to measure it, how to identify this uncertainty. We came with one factor that we believe should have an impact, and actually it had an impact in our opinion, but still we are two. And whether the numbers that we got, they are arbitrary numbers because we are excited about it, or that was kind of truth. So we came with a hypothesis, the uncertainty in the attack potential when considering attacker capability, one, is equal to the uncertainty in the attack potential when not considering the attacker capability. We said, let's consider now, we have hypothesis, and this hypothesis says that the uncertainty when we do not use the attacker capability is the same as the attack potential when we consider the attacker capability is equal to the one when we do not consider the attacker capability. So, and the goal is to prove that this is false, whether we can prove that this is false or not. So, if we prove that this is false, it implies that attacker capability, it has a value in the risk estimation, and we should consider it as one of the factors. So if we cannot prove the opposite, then we cannot conclude based on this statement, right? So we took the example of 7 threats for connected vehicles, and we send the information to experts that we know they work on cybersecurity, or they have exposure to knowledge about attacks to cars, connected cars. We did that in November 2013. So we did this example. So 7 threats. We got response from 9 experts. The data, it was complete. And the date, it was 2013. So what we found here is that the average, considering attacker capability of the uncertainty for the 7 threats, was 2.23. And the average when not considering attacker capability was 5.20. So the 5.20, that uncertainty is, as you can see, is higher than 2.23. But we can see the value are different, but whether this difference is meaningful or not, we have to go to the inference from statistics, and based on the t-tests, this is 99%, they are different. And the effect size, another metric that we use for statistics, effect size, is 2, which is more than the threshold we use, 33. So this difference is of practical value. So we did it with 2 cases, two studies like this. So this is one. We had another one in the paper. So considering attacker capability with this evidence reduces the uncertainty in the risk estimation. So my suggestion, if you are going to do risk estimation, one of the things that you start looking for is to see the attackers, what are the capability of the attackers. From there, you should consider that as one of the items that you use. Obviously, whether the hardware is available, whether the scripts are available, although we did not prove whether that's correct or not, so you might consider them, but attacker capability should be the one. Is there others? Probably, that needs probably more studies to do. So that's one role. So one role is that we have a set of methods and a set of techniques on software security and empirical research. It helps to mature these methods and these models through going to the expert and bringing some data there that help to improve them. So that's good for what we learn about method, what we did for research. But can this help me to address my everyday problem? I am in a company and I work on software security. Can this empirical research help me to work on my own problems? And the role here, the second role, which is also very classic, is that it allows to identify recommendation for solving problems. We take here example of a study that we did it at IBM, and this is related to DevOps. So at IBM, they have a system for business analytics application. And they develop projects that for the business analytics. So you could see how things complicated, different infrastructure. They have for the analytics, they have two tools here, software, prediction, Watson Analytics or SPSS. They have their IBM information server and a lot of things that they could use to develop a new application for business analytics based on the demands. The classic approach for developing application is that you do development, you packages, you make a package, then you get kind of a release letters, and that everything is in that package, and it's worth pushing to the production, and you get a set of signature, so you could push it to the operation. And the goal here is that if we're going to have problems, it's already so we have we did a good analysis of when before to push it to the production, and it's worth to push it, and probably there will be risk, but we study them in advance. So this happens in the release letter. So this is good. We have development, we have operation, but there is security tendency. We have been working on Agile, and this is kind of great, but we finish Agile on the end of the development. Now we need to push it. There are two different processes. If we combine the development and the operation, not to combine them, but actually to connect them, then we're going to have an added value. So from operation, you could have feedback, and from development, you could have collaboration. One thing, easy thing, is when you develop an application, and for security perspective, you're probably going to study it or prepare it based on your development environment. But what you need it for the operation environment. If you have problems, you want them to go fast to the development and come back to the operation. So we need that feedback loop that would improve the way that how we manage software. Based on a study on CA technology, they did what are the obstacles that are stopping company from adopting this paradigm of having the development and operation strong communication there. And the top one was security or compliance concerns. And this is with 28%. Difficult to justify from an ROI standpoint, 27%, organization complexity, 27%. So you have different factors. But the top is actually the security and compliance concern. If they solve that, then that helps to do it. That's actually what was the case also for this kind of application at IBM. They have a problem for security concerns. And the question that we have here is, what are the security aspects that should be considered when automating the development process, the development and deployment process? Remember, we have a development process. You can have continuous integration, but when it comes to the deployment, those are separate. You have release notice there. So, and the goal is that you can push things from the development that can go to the deployment in smooth way. And the question that we posed here is, what are the security aspects that we have that are there, and we need to consider when thinking about the DevOps process. So we studied there 5 projects. 1, it was automated already, and 4 that are manual processes. And we interviewed 9 participants. They were from the testing, developers on security, project management. So we had variation of roles. So we interviewed these participants. So we have an interview. Then the classic way for interviewing. So you have the interview, you prepare, you select your participant. You execute semi-structured, you have the interviews, you transcribe your interviews, then out of this transcription you code them to get meaningful information useful to answer the question. Once you have those codes, you have data extraction, then you classify them so to get the aspect that you need. And obviously you will analyze the results that you got. So when we did this analysis, we identified first item, probably it's not related to security, but it's related to the manual process, why they would go to the DevOps. So one of the criteria is the lack of qualified personnel. So you might have, you want to push to the operation, but the guy who is going to do specific tests, he's already on vacation and you have probably to wait. So if you have manual, then you might have a lack of qualified personnel at the time that you need it. And for example, someone is qualified but he is on vacation, you have to wait. There is the problem of difficult collaboration. So this is mentioned 5 times in these interviews, or 5 items that are related to difficult collaboration. There is the lack of good documentation. So we had also 3 items that were mentioned for the lack of documentation. Frequent human errors. There is a lot of errors when you have manual process. And obviously if you have error and you have a process, then if you expect your application to be up, it's not up on time. There is a lot of manual tests. 5 items related to manual tests. This is also a problem for manual process. There is a lengthy deployment. At some point, they wait 1 week until the full process is executed to have the application up, which is very long, especially if you want tomorrow to use the application. The customer wants tomorrow to use the application. The application is ready. Come on, guys, can I use it? No, we are still working on the deployment. So, lengthy deployment, 3 times it was raised. So, you have a problem now, you probably cannot go and justify your return on investment. But from security perspective, this is our main question. What are the aspects that we need to consider? The first major thing here is separation of duty. We did before a study for the literature, and separation of duty, it was mentioned, but it was not really dominant. For this application, it was dominant that the interviewers, one of the main concerns that they have is separation of duty. So the developer should not be the one actually that takes care of the operation, or should not be the one that takes care of the security review. The enforcement of access control policy. So if I am a developer, so I might have access to the database, so I could fix my codes depending on everything there. But I should not have access to those records in operation, right? I shouldn't be allowed. So I can write with some data, specific ones, to fix my code, to write the code, but the operation one, I shouldn't. So if there is a connection between development and operation, that aspect of enforcement of access policy should be there, especially for this case, access to data. The third aspect was the manual security tests. So they do a lot of penetration testing. Things are manual. If you want to go for the automation, you have problems. You have many manual tests that are not automated. They have also one of the main concerns is the audit. When they have applications, before they push them to production, they go through the audit. And now they should consider the audit too. They have security guidelines. So they want to consider that these security guidelines, how they are applied, they should be in the automated process too. How to manage security issues and mitigation. When they discover vulnerability, now how the process when you have the development and operation connected, how things will work. There is also the security team, they are participating in the manual process, and there was a concern if you have an automation for DevOps process, someone probably is going to push things from development straight forward to the operation, and the security team, they will not be aware about that. And there was a concern about that. So those are seven concerns that we identified. We're going to have a look here for their separation of duty. So you could see here we have development team, we have basically the integration and testing team, a central team, and we have production team. So you have the application, development of the application. They do lab tests, and from lab tests they go and they prepare their packages. Once they prepare their packages, they give it to the integration testing central team. The ITC, they perform the tests. Then if they have, they confirm the environment, everything is gonna run on the product, on their environment. And they push it to the development again. So this is now, it's ready, so you could do your testing, user testing for the development. They do the tests, they could fix bugs if there is any issues. So they loop there. If everything there, then they provide the release sign-off, so they could push it to the production. Once they have that release sign-off, the ITC, they got the package, they got the release, so they could push it to the production. They give it to the next third team. So the third team, they could work with the pushing things to the production, but they have also to get that change management request signed off. So we see to the minimum here, big three teams that they work. And separation of duty, they don't want someone who does development to probably participate in the code that is in the test environment. If he is going to do anything there, then that might compromise the package. So obviously we can talk a lot about this separation of duty and how things can go wrong, but basically this is the idea. They also identified 4 best practices for the transformation to DevOps that based on their experience from the first project. You need good documentation and you need logging. So from development activity, you do good logging. From pushing to the test, you have a good logging. To pushing to production, you have a good logging. In case of problems, you can go back to identify if you have anything that you need to do. You need a strong collaboration and communication. So they have it already for manual process. They have hard time for collaboration. But if you want to work on DevOps, secure DevOps, you need strong collaboration and communication. The third obvious is the automation of process. And the 4th items is the enforcement of separation of duty. So it's best practice to have an enforcement of separation of duty. So we have now 2 roles. We've seen from the empirical research. The first role is it helps to mature the methods and the techniques that we have for software security. The second role, we could have from practical point of view to study problems and come up with a recommendation from the expert. So you go to more people, you bring that wisdom, and that wisdom you could use it. So IBM, the last communication I have, I think probably 2 weeks ago, they said that they got those recommendations and they implemented them for the other project, which is, it was good, useful for them. So the third rule, this is a talk when IBM, this is IBM Germany. So this is where I was before. So the rule 3 is that we have a lot of accepted truth and or self-evident statement. When we started security, there's a lot of several professors that they have weight and they come up with a statement. And as a student, we got those statements and we believe that those are truths. And some people, they come later on with something that we like it, probably it's well written, and we use those are accepted truths. Empirical research would allow also to verify these accepted truths. Whether this is what we believe is correct and we accept it as it is, can we prove it, whether it's true or actually it's not? So I give here examples. So at the first role, I give more detailed application. The second one also more detailed example. Here, for example, there is one truth that probably when we talk about the time to fix security vulnerability, whether this is a cross-site scripting, SQL injection, or authentication, or whatever, we would jump and we say code complexity, this is the factor that is the most important, that what we should consider when we do the estimation of the time to fix security vulnerability. The answer actually is not. So we did a study, and this study, it's on 2004 at SIP, and we found, I think, more than 50 factor. And the one, probably one of the most important, is the skills of the developer. How good they have skills, their skills to identify these vulnerability. So that is also very important. So not only that you have the code complexity, but also the skills and the experience of these of the developers, the type of vulnerability, and so on. So this truth that code complexity, this is the main factor that you should consider for when saying that you are going to fix this vulnerability in 3 days or in 2 hours. You should also consider who actually is going to do that. How much experience does he have or she has? So the second one is when we talk about agile development, we talk often that there is a mismatch with software security. And this is kind of something people, they have it, there is a mismatch. We have software security, you need threat modeling, you need risk, you need design, and you need implementation. If you have a change, then your design is not correct, then you have to do things again from scratch. Because for agile, you are going to iterate often. So we might go with this simplistic idea and jump there. So we did an analysis of the literature. What are the literature that they are talking about how to apply agile and software security? And we come that there are items that there are problems that needs to be solved, and there are items that actually it's okay. And the practice is companies, they use it already. So because they avoid these problems, or they have solved these problems. The third item is code vulnerability at the code level. They are the main software security flaws. So this is here, we have a study for one software, Zencard, but I refer here to the IEEE cybersecurity report top 10 flaws. And in this report, they say based on a study that they got code from big company, there are as many vulnerability at the design level, authentication, authorization, as you would have also in code. So it's not that the code vulnerability that are most frequent. They are actually probably from academia and so on, people, they report these, but the design flows, they are also very important. From publication or from when we talk to colleagues on DevOps or SecDevOps, we report that the collaboration problem between the developers and the operation and actually the automation of the process, those are the main concerns. We've seen now for the study that I showed that probably for the case of IBM, separation of duty is one of the main concerns. We identified more than these. So these are kind of truth that we have on the talk that we say collaboration automation. This is really what you need to solve, and you could have SecDevOps. No. For the case of IBM, it was the main thing is the access control and separation of duty. Those are the two items among the top that they need to solve. If we consider malware, whether this is software security or not, we had also a study in 2016. We got 1,000 recent malware, and we tried to see whether they access the files, they access the registry, they change the file system, they change the registry, or they access the network or not. So for each, we give it about 2 minutes to check whether this is true or not. This is kind of also, it's believed that when you have malware, they are going to change the file system, they are going to change the registry, and they are going to use the network. And we found for most in general, so they did not exhibit this behavior. At least the recent one, they are not exhibiting this behavior. They are slow, calm, they do not give you much opportunity as it was before to identify that they are behaving. So we have 3 now roles. And the 4th role is actually now, what about if I have new problems? If I have new problems, I could jump myself and I could solve it. But empirical research, they could help you to explore techniques for solving the problem. So we take the case of incremental development on software security. For the case of software Zencard, this is an open source for e-commerce. So it's one of the main open source for e-commerce used. And we took that, the software, and we studied the vulnerability. We studied different aspects from security perspective. One of the things that we did the interview for the security lead. So we want to learn from him security aspect that he has for Zencard. So that would help because this is incremental development too. So we got first few remarks here that needs to be considered when we talk about incremental development. The changes to security requirement of the payment current history implies for their case complete assessment. For every 2 years, there are new version for the PADSS. This is for the banking and the payment. For every 2 years, there is a new version. For every 2 years, they stop the development. They spend about 2 months to do the evaluation. So that 2 months is kind of 10%, which is time lost. Code changes may impact security mechanism. If you do code change, you might have your authentication authorization broken. And that happens from time to time. So you have to be careful when you do code changes. If they change even the framework that they use for the application, for example, because they use PHP, if they use a new version of the framework or other library that they could use, this might imply that their security mechanism, they are not valid anymore, and they have several cases. So they changed the framework, not their own code, and some security mechanism, they don't work the way that they need to. Based on, so he scanned over the code, and for 50 comment change that they commented on, because whenever they got a change, first thing is the main developers, they discuss the impact on security or the impact of the change on security. They found that for every 50 comments, one of them, it concerns security. They have to be careful about it. If they do not, it's security broken. So those comments that we have, we can see that the code changes, they potentially have an impact on the security of the software, and they have to be careful about it. So we have a case. Now, what is the solution to work with that problem? So one simple solution, like the PADSS, is to do full reassessment. Every 2 years, you need to do full reassessment. You go to the code review, especially the manual 1 penetration testing. You have to do them full again. There are solutions, actually, practical 1. Practical 1 for their case. The first thing is when they have a change, they discuss the impact of the change on the software security. So they have an evaluation there. In another company that we studied, so they do peer review of the changes. They have, at the end of each sprint, everyone gets his code, they sit together, and everyone gives to another developers that they trust to go and to check what is the impact of the code changes that they did on their security and whether they have vulnerability there or not. That case was in Germany. So here in US, I had one company, and we went through them, and what they do, for example, they scan the code for keywords. So if you are using specific libraries for cryptography and so on, they would scan the code for those keywords, for the method that you have, for the library that you have. If you touch these things, then you have security aspect someone needs to verify. So keywords. This is another approach. Another one is that the developers, they added a comment. When they do change, they added a comment there and they say there is a potential impact of security of this portion of code. That implies the code needs to be reviewed by security expert. So, or actually they potentially, there is one of the solution is to add the annotation to the software. So to say that this related to authentication, this related to authorization. Once you have this annotation, you could scan it and you know this is authentication. You have to be careful about these methods. So this kind of existing now solution, but this is from people who deal with the problems, how actually they deal with it. And the goal at some point is to come up with a way that should work, practical way that should work. The default way is you do reassessment, full reassessment, right? So this is one aspect that we are working on. Before going further, so it's nice we have, we're almost now on time. So we have empirical research. We could use them for, we have 4 roles we specified for software security, but there are limitations for that. And the limitation for empirical study, we call them threats to validity. Threats to validity is a specific way in which the study might be wrong. So things might be what we are reporting is wrong. If you refer on the first study that I showed, we talked about the t-test, but we also give the effect size. That implies that this is practical value. From statistics, this is correct. It's possible that the study, you forget to do that, or that probably that value is not good. So you cannot have conclusive results. If you choose also you have a study, then you did not go through the participant that represents the domain, then you do not have a good picture. If you say that you have a good picture, that's not true. But if you say that you have perspective of specific people for specific case, then that would applies. My question here is how to assess the validity of an empirical study. Who's going to answer it? He's going to get this book. How to assess the validity of empirical study. Let's try.
You benchmark it, you bench those different empirical studies about the results of what happened from doing them against real world situations?
You do benchmarking against, so this is the first one, and this is you identify your question, right? How to find out the theory and the practice.
You have to go back to reality and say, okay, did the empirical study really achieve the success we were looking to go? And it depends upon how you define success in the empirical studies versus the normal processes you used before.
I'm going to give here, it's a good question. So if you, here I'm saying assess the validity. If you say success, then implies that you apply your empirical research again and you check whether it's valid or not. That's a replication. So if you have an empirical study now, how you assess what are the limitations of this study? If I reform it, how you assess that this study has a limitation, specific limitation?
In the study, did you qualify what you were looking at before you started? Or did you say we're focusing on these things?
Mm-hmm. Which one probably? Could you remind me? I'm going to make this question simple. It's just a reflection on we would know that mathematical perspective is something, and when it comes to empirical research, you could prove that, but here it's different. Would it be okay here if I did not say that the effect size is 2? If I said that the effect size was, let's say, 0.2, would that be okay? Can I have a conclusive results here? Can I claim this result? I cannot. That's from statistical perspective. I cannot conclude that. So that's an example. So empirical research, they are not, so one, get it? So we have a study here about threat to validity, one chapter in the book. So whoever wants to get good answer can get this. That's a gift for today. So you have a lot of criteria that you go to analyze your work and your result and how you did things to know what are the limitations of your study. Empirical research, all the time, they have limitation so far. So whenever we say things, it's not as complete as if you write a proof. Although proofs also you have assumption, right? So with this, I would say that when we talk about science, or at least our hard science, we talk that we have causality and we have repeatability. We can repeat things. But when we talk about empirical research, we talk about observation in general of patterns. This is what we get. But we have observation, we have patterns. It's better than we do not have anything, right? If better than we have only opinions that we use. So, but observation should help to identify causality and repeatability. So if we have a lot of patterns, then we increase our knowledge and potentially we can come to causality and we can come to science. So this is the last slide for my presentation. I hope I convinced you about the value of empirical research for software security. So I showed 4 roles here that we worked on. There are probably other roles that empirical research could help with, and we could have better way for to develop secure software. So thank you.